as I was shooting this video, my battery died, but it was close to the end. So at the very end, you'll notice that I'll come back to a video kind of like this, where I'm holding my camera physically. So, alright, enjoy the video. Hello and welcome to Basic Computer Help. In this episode, I'm actually going to talk about how the Arduino accepts programs from the computer into the Arduino. I will not be doing any on-computer work or actually anything functional in this one. But this question actually comes from a friend of mine who is learning microcontroller programming and is actually interested to know how you get information from the computer over into your Arduino. Also back, especially when he learned that the Atmega 328P does not have any capabilities natively to talk to your computer. But he's also extremely new in microcontroller programming, so I will actually dive into it. The first thing is first, there's actually two microcontrollers on the Arduino Uno. If you have an older Arduino, you actually have an FTDI chip located in this general area. Now, I actually have removed this chip already. But inside of this chip is a, you have RAM, EEPROM, stuff like that. So what happens is this chip actually loads into the SRAM of this chip your data from your computer and then installs it into the main program memory using something called a bootloader. I will try to go into more detail. This might be hard to understand. I will also post a link in the description to mikeselectricstuff on a video of a very similar topic. Alright, in this chip you actually have programmable memory. And let's say yours is takes up a quarter. So everything in here is your main program memory. What happens is you also have a bootloader. This chip has bit flags. One of them is called a bootloader bit flag, which means that there is data somewhere in the programming memory. With AVR, it's in the top. So this is your bootloader. Every time you plug your Arduino in, or every time you pretty much reset it, or the computer sends a command if you have an auto reset bootloader, auto resettable Arduino like I have, then it'll run this code first and this code second. That's why it takes about 5 seconds for your actual program you have to load up. Also, you have a few flashes of pin 13's LED. So what actually happens is you have the Atmega 16U2, which will take data in from your computer via USB. Whoops. My handwriting is not the best. And convert it into something that the Atmega chip down here can actually read. Whoops. And of course it would send data back if you had some kind of monitoring program written into your program here. This program in the bootloader starts up first and then it listens for a command from your computer. I forget what this particular command is, but it's a very specific command. So if it detects that that command has been put in, then it'll stop. It'll stop loading and go into programming mode. And then it'll send a command back to the computer that it's ready, and then the computer will actually send it all of the data. Inside of your Arduino is some SRAM. It's just simple memory space it gets destroyed every time the Arduino gets shut off, or at least theoretically it should. So it'll take program in from your computer, put it into SRAM. After it's confirmed that it's got 100% of all of the available program that it's going to take in, it'll then go, okay, take all the data that's in SRAM and move it down here into your main program space. And then it flashes the program. The reason that it does this is assume that 50% of your program itself got downloaded and then something happened. You had a power outage. You tripped over your cable. There's about 1,000 different things that can happen. Your cable was bad, and if you moved it a certain way, it would lose connection. I've actually had cables like that. Well, then the SRAM would get destroyed, and it would not corrupt your program data, which is actually pretty cool. Another cool thing is this actually only really has a converter program in it. It's designed to convert one way to the other. It's just an FTDI chip that's a little more expensive. So that's all it's really there to do is convert. So every time, even if you use, like I do it all the time, use serial.begin and serial.writeLine, pretty much it installs a little extra program in here. I think it's already in here. Or that just communicates back and forth. It's actually very simple. I know this is very basic and very basic information on it. It's probably very rudimentary. Like I said, I will put into the video description a link to Mike's Electric Stuff's video on how to actually flash a chip without using an in-circuit serial programmer. By the way, for a quick reference, be careful when you're removing this chip. Previous take, I removed this chip and damaged one of the pins. Actually, I damaged a pin on both sides. So now I no longer have access to digital pin 8 or analog pin 5. I could do everything else as long as I don't use those two pins. Thus, it's also, I can't use the I2C bus that's in here because that's attached to analog pin 5. Alright, for people that are wondering, I actually ordered a new chip. I'm waiting for it to be shipped. It's been pre-programmed from Adafruit with the no-weight bootloader. I'm going to have to play with it a little bit to see how it changes from programming it, because I'm pretty sure something will be different. Alright, until then, until I receive it, have a nice day.